Welcome to the EVMMAX implementers call number 3. And to start off, can we get some updates, maybe from Rick first? Can you hear me?
I barely can hear you, Kev. From who first? The update?
Oh, sorry.
Yeah, you're kind of a little bit choppy. I guess Radek, I think.
Yeah, I can give some update. So basically, I've been working last couple of days on some examples with EVMMAX, and I prepared the example with Poseidon hash implementation in EVMMAX. I can share. I just sharing it in the chat. This is just a PR to EVM1, which implements Poseidon hash using EVMMAX opcodes with the vectorized and non-vectorized version of this. And yeah, so there are some statistics basically, but I think the main thing I would like to present is that it's possible to implement this hash with quite efficient way with EVMMAX, and assuming, of course, some cost model, very simple cost model, that every addition and every multiplication is just, even if this in this vectorized version is just I believe 1 and 2 gas. Everything is mentioned in the PR. We can implement this Poseidon hash like the cost below the 5,000 gas cost. Yeah, so I think it's good if everybody would be able for the next couple of days to review this and go through this and give me some feedback on this. Yeah. So there are benchmarks which not only calculate the gas cost of this implementation, but also the gas rate for this implementation. So we can see that we have still a lot of space to lower the gas cost for part of the instructions, and even try to go below 3,000 gas per one hash. I think that's my rough estimation now. You can also see at the bottom. The number of opcodes and the opcodes histograms used for different cases. Yeah. So yeah, that's one thing. I also recently started working on the implementation of Xmod precompile with the EVMMAX, using some implementation of the EVMMAX opcode support in YUL language, so Solidity intermediate representation. And but I haven't finished yet. I have some results already, but I would like to wait until with the presentation. Until I will have something more more general, I would say, and something which I would like to also have a feedback on.
Yeah, this is great. Could you say what was the CPU time difference between the SIMD version and the non-SIMD version?
It's not exactly the SIMD version. It's a vectorized version, but without any usage of the SIMD instruction, processor instruction. Yeah. So, but it helps a little with the code size, of course, because we can have a smaller code size. But also we also can save some time on switching context between the EVM and the instruction computation. Yeah, because vectorized version, especially for matrix multiplication. We just do one like free multiplication at once without going back to the EVM context. Yeah, so that somehow also helps. The CPU time you have, I believe, Pavel, correct me if I'm wrong, because I'm not very familiar with the EVM1 benchmarks, but the CPU time you can see in the third column of this table in the PR, and the gas rate, of course, in the last one with gas used. And of course, what's also important in this PR, I also assume that we somehow introduced already gas repricing for push opcodes. And even with this, so I lower all the push opcodes instruction cost to 1 gas. And even for this, with this modification, we have like 200 million gas per second now, the gas rate for this. And
yeah, so like quickly computing from the log, from the benchmarks, it's like 10% faster in CPU time. With the comment what Radek said, it's not strictly any optimized underneath. It just saves you the interpreter loop time, and yeah, mostly you don't go outside of the instruction execution very often.
Yeah, and this example of the Poseidon hash is the example taken from Chance implementation in Solidity, and this example works on input of two fields, which two values, which each of them is 256 bits. Yeah, so not as a next step, I would like also to implement something like with this for the smaller field, and probably for this case it would be it would have much more sense to use the SIMD instructions.
Yeah, I agree. Yeah, and it'd also be interesting to see the speed difference between the smaller field and I guess this was BN254. It's pretty exciting. I'm pretty excited to see the difference between the small field non-SIMD and the small field SIMD. There were sort of estimates that we can sort of reduce the time by like 100x, but I'm still dubious. I'm pretty curious to see what that comes out to.
Yeah, and also what's worth mentioning is that for this case we need like we waste, maybe not waste, okay, that's we waste like 30% of the time of the gas cost, basically. Not I haven't measured time for this exact part, but at least from the gas cost, we waste like a 30% of gas for constant initializations. So for this hash, so it means that if we will have a higher level interface for this, like for example, it will not take only it will not be the typical hash function, but for example, it will be just a function implemented and which implements just a proof verification. So it will run this constant initialization only once and just calculate the, I don't know, like 32 hashes or 16 hashes at once without reinitialization of the constants. So probably it will amortize quite well, and we should also have much better amortized result of the gas cost of this proof verification. So, but yes, that's another thing I would like to prepare a use case for.
Okay, do we have a way to do that right now? So we initialize the constants like once and then
no.
Okay, I see. Okay.
No, we don't have. That's the question is if it will be really needed. So the answer is, if you want to have because I assume that EVMMAX will be just a tool, and everybody will be able to implement their version of the functionality they need. And if someone will need the proof verification, probably this constant initialization will not be a problem. But if someone would like to have only hash function used by others, this 30% of the gas probably will make a difference for them. But yeah, that's not sure. But we have to decide maybe later if it's really worth researching on how to initialize these constants better than it's now, because yeah. Yeah.
Yeah, that makes sense. I think it's great that you sort of pulled it out so we can always know what the exact percentage of initialization cost is to the total cost.
Yeah, I will also prepare some CPU time benchmarks for this constant initialization, because the gas cost, it depends on the how well the gas is defined. The gas cost is defined for, in this case, for push instructions, and for this data copy version, for the data copy, basically opcode, how it's close to the real CPU time. And if it's overpriced, probably it will. If it's strongly overpriced, probably the cost of initialization regarding CPU times will be much lower. So yeah, but not sure about it at all. So I will check it.
Okay, I see. And do you think that we need to reprice other things? Because I think you said that the ad and mul were priced at 1 and 2 gas.
Yeah, for in this case, yeah. So, but and for this vectorized, I haven't introduced the gas model Jared prepared in the EIP. I just used the model from non-vectorized version. So basically, just the cost of the gas cost of the vectorized version is just the cost of the sum of the all single instruction in the vectorized form. So, but I think I wouldn't put too much attention to the gas cost. I would focus on the real CPU time, and in time we can define or use any gas model which reflects the CPU cost well. And I haven't checked how exactly the gas cost model is now defined in this Jared's EIP, but I used only the definition of the opcodes.
Mhm. Yeah, that makes sense. I guess one thing that might come up is that if we don't have something like fractional gas, then it's unclear how we're going to price this in like a fair or / competitive way. If you just can't get below 1.
So one option that I think has been floated before is to do fractional gas for the each operation in the so you have a vectorized invocation, and then however many arithmetic operations you do, you charge the cost model for each arithmetic sub operation charges a fractional gas, and then you would round up to an integer value. I think that's been somewhat floated, but I don't know. That was also just an idea I had. But yeah, I think that is probably something to explore down the line if as the implementation with smaller fields is explored.
Yeah.
So I just have one question. Is the the vectorized version should be compatible with EIP 6690 other than gas costs? is there standalone EVM bytecodes for these available? I'd be curious to see how it performs in Geth.
Yeah, so yeah, it's exactly compatible with this AIP except the gas model and the bytecode. I believe it's available in the PR. If you look at the one moment. I believe in okay, I will send you the link to
Okay,
the
great.
bytecode. But yeah, so yeah, yeah, sorry. It's even easier. I've just because I've been doing this like a couple weeks ago and already forgot where exactly it is. But yeah, it's
Okay.
yeah, so I will send you.
Yeah, cool. Two other questions. One, where I just started glancing at the PR, but what does the overhead from push come from? Is that from storing the like constants that you're using?
Yeah, exactly. So for this non-data copy version, I just use the basically uh, pushing all the values to the stack and then transferring into the EVM memory and then to EVMMAX context as far as I remember. Yeah, that's
So,
exactly how it works.
okay, cool.
But
So we could
from the
effectively
data,
consider those to be not, I mean, like in a in an implement the implementation could embed these in a data section
yeah,
and move it to memory without the need to push.
yeah, exactly. There is a version also with the data copy
Okay.
opcode, which doesn't require pushes. But the cost, of course, regarding the gas cost is of course much better. It's like I will tell you, it's like about 1,700 is for push version, and about 1,300 is for data copy version. So when the total gas cost is like 4.2 thousand. So yeah.
Okay.
Yeah, so there are four different versions of the bytecode, and they are linked in the PR comment.
Okay. Do you have I would be uh I guess I would be curious if there's a rough idea of what the added overhead would be if because I'm assuming like this is unrolling
Unrolling loop. Yeah.
yeah.
Yeah. Yeah. Yeah.
Um have you done any like napkin calculations or just rough calculations of what the added overhead might be if we were to like not unroll this at all?
Yeah, yeah. So I haven't done it yet, but because so basically for Poseidon Hash, it was quite easy to implement this as I did with just unrolling loop. But of course there is another exercise I need to do is to implement this with this EUL version of supporting EVMMAX opcodes. Because and try to benchmark this and measure the gas, of course. But from so but first I need because now I'm using this EUL version for implementation this export precompile, which is much more complicated regarding regarding the control flow of this precompile. And that's why I decided to use to make it in EUL, not in the raw bytecode. But what's worth noticing that this EUL version, at least for now, is based on the in support in Solidity is based on the first version of EOF support in Solidity, which has implemented none of the regular optimization, which is done on the assembly level. So probably the code will be not very efficient.
Okay. Yeah, great work. Looks awesome.
Yeah, thanks, Radek. Are there any other updates?
Yeah, I have something that I was I was kind of reviewing our like EVMMAX like code for a BN curve. Because we kind of started using this as a implementation of the precompile to some level. And and we switched from so to compute the inversion of the element in the field, we used add chain that implements the exponent, and we did experiment to switch to Euclidean algorithm, and that gives us like 5 times improvement in performance in this area. None of these either add chain. So add chain is the best we can have, but the Montgomery multiplication underneath, it's not fully optimized, and kind of the same story is with the Euclidean algorithm. So it's not really like fair comparison because we didn't nail any of these to the optimal level. But still, I think 5x improvement is significant enough that I started considering adding this as an instruction to EVMMAX. Not sure how you feel about it, but definitely on the like precompile implementation, it make a difference. Yeah, and we were able to actually finally pass the previous implementation we had from some external library in terms of performance of these precompiles.
Oh, the 5x wasn't in EVMMAX, was it? Was it using EVMMAX?
Well, it's kind of, so we have like EVMMAX. So we have a like C++ module that implements EVMMAX. In a sense, the API is kind of the same. So you define a modulus and you have 3 operations: addition, subtraction, and multiplication. So it kind of mimics the EVMMAX instruction design. And this is also used to implement EVMMAX instructions. But we can use that on like native level as a kind of API. And so it's like mostly some of the precompiles we have are implemented this way. But to be strict with the EVMMAX model, we didn't, there was no like inversion instruction, let's say, and we used chain because it felt more compatible with future EVMMAX evolution. But yeah, obviously we can switch to Euclidean algorithm internally without modifying EVMMAX, but it seems it's very beneficial to have it as a separate instruction, actually.
Yeah, and also from my experience with Xmod, there is also a case for Xmod where calculation of the inversion in the power of 2 field in this case is needed, and implementation of this inversion in EVMMAX using this UL is kind of difficult. Basically, it's difficult, and it would be very beneficial and convenient to have this as a separate instruction, especially that the algorithms for inversion for power of 2 fields and odd field is well defined. Yeah.
Yeah, I think it makes sense. I mean, if you're doing sort of anything to do with elliptic curves, you're probably gonna want to use inversion and probably square root at some point. So adding the inversion in as an instruction makes sense. And if we're not using addition chains, it means that you can actually implement it as a efficient procedure. Because addition chains, you need to know what the exponent is sort of beforehand. But if you're using the Euclidean algorithm, it's just a generic. You can pass in the modulus at the runtime. So yeah, I think it'd be a good idea to have an inversion specific opcode there, unless anyone that disagrees.
Yeah, it also shrinks the kilobyte of code into 3 bytes.
But you say is that from 14 kilobytes?
Well, it's like AdChain has around 300 instructions, right? So you replace these 300 instructions, which is around 1,000 bytes into like single instruction. So it also massively saves the code size.
Right. All right. Mm. Cool. Yeah, thanks for the update. Yeah, and if no one has any opinions against the inversion opcode, I think we can just move forward in adding it. Okay, cool. Are there any other updates? Cool. I guess we can look at what we mentioned last week. So confirming the EVM gas numbers and the wall clock time for Poseidon. So yeah, this is done by Radek. Implementing and comparing the legacy Solidity version of Poseidon hash with the EVMMAX bytecode version. So this is also done by Radek. And I think the last thing that Chance is not here was to investigate SIMD comparisons using AVX2 for small fields and BN254 for Poseidon. Radek, I think you said you're probably going to pick that up.
Yeah, I think I will be able to do it for the next call, assuming that it's in a month from now.
Mhm. Okay, cool. And yeah, I'm not sure. Does C++ have good SIMD? Does it have a good SIMD API? I've never used.
No idea actually at the moment, but probably it has. But so we can just use. Okay, probably it has, but not sure how efficient it will be because I'm working on the Apple Silicon processor, not sure how exactly it will look here. But in case it will not be possible to measure it in the correct way, I will try to use different machine.
Okay, I see. Okay, cool. That sounds good. So we can carry that task forward to the next meeting. Was there anything else you wanted to sort of put on your task list, Radek?
Yeah, I will also be pushing this X mode precompile, and we'll try to prepare some similar report for it as I did for the Poseidon for the next call. I will try also, maybe if nobody is against, I will try also to extend the EIP with the inversion instruction. I will push the PR to this, and yeah, I think that's all for this couple of weeks.
Okay, that makes sense. And would I guess the inversion opcode, the SIMD version would allow you to invert multiple things in parallel, is that correct? Or is it one?
Yeah, that's how I implemented this already in EVM1, but only for the power of 2 modulus.
Okay, nice. Cool. Is there anyone else who wants to sort of mention what they'll be doing for before the next meeting or something, or any questions?
I just wanted to ask quickly, like, do people have opinions over proposing EVMMAX for like a specific fork, like maybe pushing for Amsterdam? I mean, from Nethermind side as well, like we don't really have any updates, and we haven't really started working on implementing it. But you know, if we had maybe a clearer timeline of like if it was going to be included soon, then maybe we could start working on it.
Radek, what do you think?
Basically, we talked internally in Epsilon regarding the timeline. I think the fork after Fusaka, so I believe it's Amsterdam. It's would be great to have it introduced there, and I think it's feasible. But of course, we need to work a little bit on the IP and prepare the version, so to let the clients implement, give the feedback, got the feedback from everybody. So maybe the retreat also will be somehow will somehow allow also discuss it with the IRG team and cryptographers from Ethereum. But yeah, so definitely I think Amsterdam is it's a good good time to introduce it. Yes, after UF.
Okay, thank you.
Yeah, I think one strong data point that would be compelling to at least maybe the like roll-ups and people like this is what is the sort of concrete performance we get with the once we have SIMD, like what is the lower bound for this? And then we can compare against whatever they're using right now. I believe most are probably using Poseidon. So if we can say something like with SIMD, Poseidon gets you 10x improvement over whatever you're doing. This saves you, I don't know, 100,000 gas or whatever. I think this is like a very strong like way to sort of put the improvements in perspective.
Yeah, regarding this, there is some discussion or some opinion from Scroll under the Vitalik's tweet I just shared in the chat. Pavel found it yesterday. So they are very, I would say, maybe not very, but very, they have very negative opinion regarding Poseidon, regarding the efficiency of this hash function. But I haven't checked anything what exactly implementation they used, if they used their own implementation or they took something from existing libraries, but yeah, so we should also take it into consideration, definitely.
Right. I can speak to them to see what they were using. I guess this post is about migrating Ethereum state try to Poseidon, which is a sort of a stronger push for Poseidon than just doing it inside of a EVM, like a contract, for example. Because in a contract, there's like, yeah, a lot of people use it because it's more efficient in these ZK circuits. So I think it might be a more nuanced argument for them, but I can definitely check what they were using and what they think about sort of using it just for like verifying proofs, for example.
I would also like to have some base of most important and most popular algorithm used in by the ZKs and LTUs. So it will be good so just to use it to implement other use cases using EVMMAX and maybe use it as a good selling points of this proposal.
Right. Yeah, I can definitely reach out to them and ask like what algorithms are you currently using? apart from Poseidon, and or at least what fields are you using with Poseidon as well? What is the cost? What would you like to see reduced? And yeah, we can just take that list back. Were there any other questions or?
I have kind of related thing. So let's say like EVMMAX end up in EVM. So how difficult is it to implement it in some ZK circuit? Let's say like it has like some natural modules, I assume, right? So where this operation like modules operation is kind of natural, but like is it difficult to switch to something else, or it's
I think it's definitely not as nice as having a fixed modulus like BN254. But as far as I know, most ZK proving systems have this thing called big num or big int. So it's definitely not nicer than having a fixed modulus, but I don't think it's like super difficult either. Especially if I guess they were doing, especially if we had something like X mod before.
but is it like for example some kind of like Montgomery algorithm multiplication
Right.
or if you have two different primes?
Right. The one that I saw being used before was using the Chinese remainder theorem, but this was by Aztec. I'd have to double check what people are using now. That was, as far as I know, sort of the state of the art, but maybe it could have changed within the last couple of months. It definitely wasn't Montgomery though. But I don't think it matters that much because the Montgomery, the internals of what's happening with addmod and nullmod is not exposed. So I don't think it, I don't think it matters too much.
Okay.
I, Yeah, maybe there's ways to optimize it in ZK since you know the moduluses of the contracts beforehand. But I'd have to think about it. I'm not sure.
Okay, thanks for the answer.
I guess one question I also had was whether, so the plan is to replace X mod with this as well. Is that correct?
Yeah, so maybe not just replace, but I would like to have another case, and it was also somehow related to the gas repricing or XMod repricing precompile discussion. And I proposed, because I implemented the Poseidon hash, and I proposed also that I can check how it could be implemented at EVMMAX regarding the gas cost, and maybe all the discussion regarding the XMod repricing will be we can wait with this change and just to release the implementation as a EVMify implementation of XMod, yeah, in the EVMMAX. But yeah, so we'll see. But this is just another case, and this algorithm looks like much more complicated than Poseidon hash. So I also would have liked to see how convenient it is to implement this. And I have already a couple of additional already comments, but I will present it later when I will have some more comprehensive report on this. Yeah.
Yeah, mostly we're trying to find some examples outside of elliptic curves that seems to be a bit more difficult to implement in EVMMAX. So Poseidon hash was kind of interesting because it has a big array of constants that you need to hash in. And this is not straightforward to do in EVMMAX. I mean, it's definitely different that you would do in native software. And yeah, X mode is also very interesting because you get the modulus from the user input, which is nothing we have with elliptic curves.
Right, that makes sense. Was there any other questions?
In terms of like, do we want to replace? I don't know. It's if you have something that it's like good implementation, maybe. There was some idea that we could replace precompiles with bytecode at some point, but it's for me it's hard to say how serious this is.
Yeah, I guess my thought was that this does introduce like I guess some complexities to the clients, right? I guess they'd have to compile like the precompile into EVMMAX, and then now they have an EVMMAX compiled contract in their repository, or is it somewhat different? Like how would it look?
Well, the idea is just to add some hard fork to just dump a bytecode at the address, and the bytecode will do like more or less what the precompile was doing, or like maybe exactly identically. I mean, there was this idea to replace the identity precompile, which is kind of trivial, and you can write a bytecode that does exactly the same thing that the precompile does. And yeah, so that's definitely can be done. It's question, is it worth the like effort? Yeah, what are the gains out of it? What are the kind of problems? And that's something we are thinking about, at least to have a prototypes of EVM implementations of precompiles. But I think until we have prototypes of precompiles to the level that it covers most of them, or like significant amount of, I wouldn't really consider it seriously, because I mean it's a lot of kind of questions related, like if you replace half of the precompiles, was it worth it or not? Like how does it help? Or I guess the ideal solution would be to replace all of them, and that's kind of clean ups the EVM design very much. But besides this, it's yeah. And also, I think I don't know. I think we like in general we weren't super great about cleaning up the design of Ethereum in general. We rather add new things instead of improving existing. So it's hard to tell like what people will say, like what is the top priority like next year's, and maybe cleanup of EVM will not be on the list.
Yeah, I'd definitely be interested to know the positives of doing this. I heard it before, but I sort of sidelined it just because it seems, I mean, precompiles have the nice UX where you can sort of update the underlying library and it just gets faster. And it's like not a thing that you need to coordinate between different clients. Whereas I guess with the bytecode, it might not be the case. I don't know. It might not be. Maybe there's a way to do it. One nice thing, just another point, one nice thing is that it might be possible to replace the underlying implementations of the precompiles with just like the API being used for EVMMAX. That might be one thing that could be done, and then it doesn't actually break any client, and it doesn't need like client synchronization.
Yeah, I mean, if it's some way if we replace a compile with a bytecode becomes kind of a spec of the precompile. So assuming it defines the same spec that before, the clients are kind of free to bypass it at least, right? This is the case already happening with the system contracts. They're not like strictly computational intensive, but to my knowledge, some clients, they prefer like not to execute EVM, just do whatever the contract would do with given input. So it's kind of like native implementation of the semantic of a contract, but the code is there. And if someone takes it and kind of ignore it, it will behave the same. I also know like for example, ZK Sync implemented some of the precompilers in EVM because they prefer that to get the like EVM compatibility by sacrificing efficiency, but at least they didn't have to create another ZK circuit specifically for some precompile. So they just implemented that in Solidity and gives the same results, right? So at least having a spec that is EVM bytecode, I think, has some benefits.
Yeah, actually, that's a good point. In that you wouldn't need the precompiles for everything. The EVMMAX opcode can replace them by. Yeah. Yeah, I think definitely we should have a conversation on the pros and cons of this to see if it's worth it, especially with things like ZK circuits and how they're affected as well.
Yeah, so like final note from mine would be, we kind of use it, the existing precompilers, at least they're related to final fields or like modulus arithmetic is our kind of benchmark for EVMMAX usability, right? If we can implement that and it doesn't look so bad, and it kind of perform like in some relation to the native, I think that's good sign that the design is capable of accumulating this use case.
Yeah, I agree. Definitely. Are there any other questions?
I have a quick question. I mean, it's quite, I guess, a basic one about the spec, but I'm just trying to understand like what exactly is the connection between EVMMAX and SIMD, because I mean they're always kind of grouped together, but I see there's a separate EIP for SIMD, right? So would it make sense to have one without the other, or like why are they always grouped together?
Yeah, I haven't clicked on the EIP yet. I had to switch to mobile, but I'm guessing it defines SIMD operations like probably as opcodes, whereas the EVMMAX API just says we have a vector of things, and the SIMD sort of semantics is sort of hidden behind this API of having a vector of things. So I'm guessing the EIP 616 has like actual SIMD opcodes being exposed in the EVM.
Oh, okay. I think I understand that. So sorry, when we're speaking about Poseidon and using SIMD, that's because it's kind of behind the API, which allows you to use SIMD under the hood, right?
Right, exactly. Yeah, if you have two vectors and you're just like element-wise adding them, you could just do that using SIMD under the hood. Yeah.
Okay, thank you. Makes sense.
Your other question was, does it make sense to have one without the other? And I'm not actually sure. Maybe people would want SIMD operations anyway. It's not really clear to me. Maybe Radek or I think Danu had a point on this.
No, I have no opinion on this at all, actually. Yeah.
You mean about this 616?
Yeah.
Oh, I don't know. Yeah, it might be interesting to reviewing, but I think it's not really related to EVMMAX, right? So it's not a crossover of the SIMD instructions in VM and EVMMAX instructions that gives you the SIMD EVMMAX instructions. So it is pretty old. I don't know. I mean, I think you could extract some utility out of it, but I think yeah, it will be some amount of work to do something useful with this.
Yeah, cool. Yeah, I guess one other thing is sort of figuring out what are the open questions that we have before we can even like ship this in Amsterdam. It seems the SIMD sort of version of Poseidon is the only one I have at the top of my head.
I have also one something which can be also worth considering is that there are a lot of different use cases where this vectorized opcodes are not very useful, and of course there are a lot of cases where they are very useful. But the question is if maybe we should have both, like non-vectorized and vectorized opcodes for this, and of course because it will basically if we have non-vectorized version, we have just opcode with 3 bytes of the immediate arguments. But with vectorized, we always need to have like 7 immediate arguments, which is 4 additional bytes for each instruction, and something which maybe we should also consider, maybe based on some more examples we should prepare, if it's worth to have like 2 different sets of instruction for EVMMAX, so non-vectorized and non-vectorized version.
So I guess the way we would figure that out is to just look at what the different use cases are and see if there's any that really benefits from having non-vectorized version.
Like for example, for Xmod, I don't see any part of the implementation where it's beneficial to have this vectorized version. But yeah.
Right, that makes sense.
I also have a question. I think we should go with AVX 256, right, for the SIMD implementation. Or do we want to look at 512?
I think we can't do 512 because that's sort of more esoteric. 256, I don't have a strong opinion on. The 128 is sort of the lowest. It's sort of the lowest common denominator, just because Neon and AVX2. So I don't know what people have opinion, what people think. Right. Yeah, good point. It's 2017. I don't know how widely adopted it is, but I might be mistaken. I can double check. But like for Max, it's Neon, which is like 128. I guess Radek, you can maybe just check for 128 and 256. I guess the performance increase would just be linear, so it'll be another 2x, but I'm not super sure.
Yeah, I will check. You mean using this SIMD instructions, yeah?
Yeah, exactly.
Yeah, I will check it, but definitely I need to get a little bit deeper into this because at the moment I have exactly no no idea how it exactly works. I know how it works, but what exactly integer size they accept and where it can be useful. So yeah.
Yeah, that makes sense. I guess the Plonky free library, they've sort of used SIMD quite extensively, so that might be a good sort of inspiration. They used it for Poseidon as well, I believe.
Can you provide some link or?
Yeah.
Perfect. Right.
Was there any other questions people wanted to ask? Okay, cool. I think we can just summarize. So there's the inversion opcode that Radek's going to add. Then comparing the different SIMD versions, comparing SIMD versus non-SIMD for Poseidon. I can go and ask the L2s or the ZK rollups who are using Solidity to like verify their proofs, like what algorithms they'd like to see getting reduced. There's Powell's point, but I guess it's not super immediate about, replacing some of the precompiles with EVMMAX. And yeah, I have a point here to just discuss all the open questions for shipping this in Amsterdam. Is there anything else that I've missed? Cool. Okay, cool. Yeah, thanks for joining, guys. I'll see you in 1 month, or I guess I'll see some of you soon.